There's so many screens I've got here. Okay, cool. Hi. Yeah, so this talk is on autoscaling, and it's also a bit on Azure Spring Cloud, and it's a fascinating new technology that Microsoft has brought to the developer ecosystem on Azure. If you don't know me, I work for the developer relations team at Microsoft as a senior cloud advocate for Java, and I'm actually part of the Java advocate team. You can follow us at Java at Microsoft, and there's really great updates that we're got on those Twitter accounts. So before I start, I've actually got a little demo that I'm going to start, and I'm going to start autoscaling in the background so we can come back to the demo and see exactly what is going on. So this is the nice little Spring Pet Clinic. You can see there I've got names and addresses of owners, and if you click through here, you can see each owner, well, let's try that again. Each owner actually has some pets. Rosie the dog, and you can do some veterinarian visits. And what we're going to do is we're going to see if we can autoscale it in the background while I talk through my slides. And how we're going to do that is we're going to actually hit one of the microservices that we can create with 2,000 high, really data intensive transactions. So if you look at this transaction here, I'm going to curl it, and it basically says, get me all of the owners. It's the entire database. And if I hit that back, I get a lot of JSON back. So you know what I'm going to do? I've got a little for loop there, and I'm going to go script, and it's going to just, and that's going to run for a while. And we're going to see the response time, and will that remain stable? And then we're going to scale up those servers, and we're going to go see exactly what happens while we talk through the slideshow that I've got for you. So let's go back here. So yeah, so we've kicked off our little transactions, and let's carry on with our presentation now. So I'm going to set the stage, and we've got a little journey to take you through. And first of all, let's also acknowledge that Spring really is everywhere. It's 50%. Spring Boot has the largest share of Java among application frameworks. And Spring's flexible libraries are trusted by developers all over the world. From the latest SNCC report, as you can see here, 50% indicated Spring Boot as their framework of choice. Most of you already have hundreds, if not thousands, of Spring Boot applications in production already. However, with this COVID climate and the digital disruption, business is growing, technology is evolving, and distributed teams are also changing. I'm speaking to you from South Africa, and you know we're part of a team, and companies are looking to become more agile so they can innovate to respond to change faster. So in large distributed projects, we firstly need to let each team independently build, verify, deploy, and monitor their services. Applications need to scale quickly to potentially millions of users across the globe. We need independent services that can be scaled based on their respective demands. And we also need to work more efficiently through an end-to-end development experience, coding, debugging, deployment, monitoring, and management with integrated tools and DevOps. Then we have a chance to actually achieve reliability and faster time to market, what we call supercharging your applications. And I'm going to show you the steps to actually go in and supercharge your applications. And really, Autoscale is the heart, and you can see that nestled in the middle of it, the heart of really supercharging your applications, because I'm going to introduce some concepts like pay-as-you-go and downscaling that are very kind of new to the world of Spring Boot and Java developers. So to achieve these goals for today's session, I'm going to act in two parts. One, I'm going to act as a developer, and then later I'm going to act as part of a DevOps team. As the developer, I'm going to explain how to build my services independently and run them globally. And when I play as a DevOps, I'm going to show you how to scale these services and manage the app lifecycle efficiently. Finally, I'm also going to show you how to deliver the value faster and introduce some new roadmap features that we're going to get to eventually. So let's get started. First, let's define microservices. And they're a software architecture style in which applications are composed of small, independent modules that communicate with each other using well-defined API contracts. Each service is actually a highly decoupled building block that is small enough to implement a single functionality. Typical microservice projects consist of a collection of these services. Besides for the services themselves, let's discuss some of the other components that appear in a typical microservice project. First of all, my services need management and orchestration components. These components are responsible for placing services on nodes, identifying failures, and rebalancing services across those nodes. As you can see from this diagram, we also have some microservices which expose external APIs to your customers and clients. In a real-world systems, this number can grow very quickly, as well as the entire system's complexity. It's much better to actually use an API gateway. So we've discussed microservices and also management and orchestration and using API gateway. Let's also look at how we can run all of these services globally. So to achieve this, I'm going to use Spring Cloud as our base framework. So Spring Cloud is a product, a bunch of libraries that is offered by Pivotal, and you can run it in multiple different types of cloud environments. So Spring Cloud really provides 4 key modules necessary for our microservices. Spring Cloud Gateway provides a simple yet effective way to route our APIs. Spring Cloud Service Registry allows automatic detection of network locations for service instances. With the config server, you have a central place to manage external properties for applications. And finally, Spring Cloud Sleuth can ease debugging by providing distributed tracing. With orchestration, typically this component is off-the-shelf technologies such as Kubernetes. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. It's got a lot of the features I'm looking for to orchestrate my microservices. But as you can see from this diagram, this is a typical workflow and that lists how Kubernetes rollouts work. It seems I have to learn a lot of, well, a bunch of things actually, like pod, scheduler, YAML, and how to operate them. What I'm really looking for is an approach to easily operate and manage my infrastructure, Spring Cloud components, and Spring Boot applications on hundreds of instances. My main goals are to set up and host a Kubernetes cluster, build and host a Spring Cloud registry, config server, and distributed tracing, and containerize Spring Boot applications, deploy them to a Kubernetes cluster, and wire everything up, all those applications with the Spring Cloud components. At the same time, I'll have to perform stop, scaling, and other operations to manage the application's lifecycle. Whew, that's a lot. Let's look how Azure Spring Cloud may be the platform that can actually let me just focus on debugging and deploying my applications and not have to worry about all of the other administrative tasks. So Azure Spring Cloud removes the burden and related challenges of setting up and managing Spring Cloud components and Kubernetes. It's actually a fully managed service for Spring Boot applications. It lets me focus on building the applications and run my business without the hassle of managing the infrastructure. We have dozens of microservices. I can automate resource management and application development using my favorite DevOps tools. If I have a big team, I can monitor the health of my applications and isolate the failures to some microservices using Azure Monitor and achieve authentication using Azure Active Directory. Azure Spring Cloud is integrated into the ecosystem, and because of that, it's really enterprise ready. So great, we decoupled our applications to microservices. Let's see how we can now scale them based on our respective demands without impacting the overall performance. So apart from reactive monitoring, I really need a built-in feature that helps my microservices perform their best when demand changes. Take, for example, Black Friday. And I know that everyone's getting those emails already from Black Friday saying special, 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 special. Your customers begin researching in October now, but the season truly kicks off in November with spikes in services and my services of my applications usage occurring throughout the last 4 months of the year. I expect to see a significant negative impact into in-store visits, but double-digit growth in online sales. I'm going to need a business and technical strategy. So my business strategy needs a way to ensure service to my customers while also minimizing operational costs and optimizing resource usage. So there's a bit of a trick to this. Seasoned CEOs have a rule of thumb that you can calculate as best as you can the maximum load, and from that, the number of instances in service that add, that you can actually run your system on, but they add a fudge factor about 20%. Then you hope that you don't get called on a Friday night when the load unexpectedly spikes. In the cloud, the strategy is inverted. Rather than allocating for the maximum load, ask what the minimum load is in terms of instances in your cloud. See, in the cloud, you can always scale up. The important thing from an economic point of view is to be attentive to scaling down by releasing instances and thus reducing the charge. You shouldn't pay for what you don't need or use. Now, remember the demo that we did there? So I'm busy scaling up with the transactions, but what I'm going to show you is that I'm also, as soon as the demand lessens, I'm going to scale down. Now, I have my business strategy. Let's look at some technical approaches. So there are 4 core scenarios I want to cater for. I need some apps to have idle capacity. In this approach, we scale the number of individual app instances. I want to scale differently on weekends. In this approach, we scale down to 1 instance on a weekend. I want to scale differently during holidays. In this approach, during the holiday season, I want to override the defaults and have more capacity at my disposal. And finally, I want to scale on custom metrics. In this approach, we scale on an app based on CPU or memory or other specific metrics. It looks like I need to configure my app to automatically scale or auto scale. This is where you schedule additional instances when you expect a heavy load and release them when no longer needed. In order to scale, your apps can be scaled to exactly how many instances are needed for the load, but never go beyond the limits that you set. It can be configured with a range of metrics, ensuring your scaling is linked to your service app or even the VM's performance. You can also set a schedule based on instance count and calendar, ensuring your apps can be scaled based on your predefined schedules and limits. The Autoscale service also provides metrics and logs to understand what scale actions have occurred and the evaluation of the conditions that led to those actions. You can find answers to questions such as, why did my service scale or not scale? Why did an autoscale action fail? Why is an autoscale action taking time to scale? Whenever your resource is scaled, an event is logged in the Azure activity log. You can view the scale history of your resource and get notifications sent directly to you. If you want to integrate to DevOps, we also provide, on Azure, the ability to tie Azure DevOps into webhooks on every evaluation and autoscale action. So enough slides. Let's go back to our demo and we'll have a look at exactly what happened. Remember what I did there is that I sent 2,000 transactions through to our application, and with the mind that I want to scale up and then scale down when the load is diminished. And this is my application that I showed you, my pet clinic. Let me just show you what happened here. Wow, I scaled up to 3 instances, and then I immediately scaled down, and saved me a lot of money because, you know, I now can use those instances for other things or lower my costs. And you can see also here, 0 failed requests on that scale. The server response time was actually very stable. So that's when it scaled over that period. The average processor time was also stable, and the average available memory was also stable. So let's see exactly what we did, and let's go through the demo in a little bit more detail. So the first thing that we want to do is we want to identify the service that we've got. So this is on the Azure samples, and I'll show you the link to the example. We took the pet clinic customer service, and the pet clinic customer service has some REST services. And the REST services that we called there was find all for the owner repository. And what that does actually is it goes into our find all service of our repository bean, and it loops through all of the JPA objects to find all of not only the owners, but also the vets and also the visits services. And if you remember in the beginning of the demo here, let's go back into there, and let's just clear that screen. Clear. Okay, we lost connectivity, but it's all right. We'll reconnect here. So when we come back here, I'll show you how that curl works again. But can you see what I'm actually doing here? This is actually a code spaces. I'm going to reconnect here for a second. I'm just going to close that. There we go. This is an Azure Visual Studio Online code space that I'm running in the cloud in the same data center. And you can see here, it's going to connect here again as my Azure Spring Cloud. This isn't my PC. I'm doing my entire development, my deployment, and also my REST services in the cloud. Let's wait for it to start up again. It's actually building my VM on my Visual Studio Online code spaces again. And being in South Africa, this is why it's important to me, because I can actually go in and use the services that are so close to that data center. So let's actually go in here. We'll come back to it eventually. So we curled there, and we curled that service there to owners. And when we did that, we can actually see, if we go into our application insights, the exact performance and the calls that we did for each one of those services. So I'm going to go into performance here, and you'll see here with performance, the first thing that we're going to be met is the spike and the location of the increase in the transaction. So I'm going to select the area that I want, which is now, and I'm going to zoom in there, and you can see here we've also got a little bit more transactions there. I'm going to zoom in there again, and you can see that we spiked up with and where's that 2,000 transactions, exactly what I said to you. Remember, I said I'm going to do 2,000 exact transactions. So we spiked up to the get owners transactions there for 2,000 transactions. And at the same time, we can see the exact metrics and also the millisecond response time. And as we hit that load, we were stable with no errors across that. And then we downgraded and we downscaled our server capacity, and we saved ourselves a lot of money. You can also get here for the request count, and we can also go in and see the samples. So you can drill down in that screen into the samples. I'm going to take the suggested sample here, and we can see the transaction, the end-to-end transaction details here of get customer services. And we can see here, see what happens before and after this request, and the user flows show the trend. And we can go back in time and see all of the specific performance indicators to see, did our scale work? So let's see how you actually set up those that order scale. And to do that, I'm going to go into my Azure portal. I'm going to go back into my home page, and I've got my Autoscale repository here. And I'm going to go into my app, my customer services. Remember, that's the app that we actually specified the Autoscale specific parameters. You can see the customer service, and it's got one node, because remember, it went to 3. But I've also got the vet service and visitor service. I've got them statically on 2 nodes. And then I've got my admin server and my API gateway. But what's this? Also, I've got a .NET service running at the same time. But we'll go back into that. But did you know you can run .NET Core app services in the same Spring Cloud as you do with your Java services? So I'm going to go into my customer service here, and you'll see there's scale out. So let's go into scale out. And we're going to specify customer services there. And then you go into that nice little view here on how to scale out to a custom metric. So you can click on the custom metric, and it says scale out. So we're going to first look at the custom metric with scale out. And I'm scaling out when my Tomcat instances, the average global request total count. So when I get more than 10 global requests averaging over a minute. So it's not a big real push though, but it's enough for me to say I've got load there. And then I actually go increase the count to 3, but I control the maximum number of servers that I actually can scale out to. And once that's done, then I've got my scale in. My scale in says that when it's less than 10, then go back in and decrease the count to 1. You also get the ability to see your scale history here. So if you remember here, you can go see the run history. You can see I also, over the last 7 days, I've tested it extensively, but the last hour, you can see that we scaled up and we scaled down. You can see there, it's got the activity log, and you can put in the notifications, those triggers, those webhooks, and enhance diagnostic settings here. So it's pretty simple, it's baked in, and it's very easy to see how you can scale. And we want to see some distributed tracing. So a view of all the services together so we can actually see exactly what happened. So I'm going to go in the last 30 minutes here, in this beautiful clustered view here. I can see my customer services, and it's 4 instances because remember, we're running on a Kubernetes cluster. So we originally had 1 node, and then we scaled up an additional 3 because what you don't understand is that those 3 actually became new nodes. We just kind of juggled them around. So we've got 4 instances here, and we can see that they called the Autoscale Pet Clinic, the vet, the API gateway, the admin server. We can even go into those services there, and we want to see those 2,000 calls here somewhere. We've got 500 calls, 500 calls, 500 calls. I think 3,600 calls. Let's just go into here. We can go into the admin server, to the customer services, and you can isolate to a specific node. So you can go filter by this node. The API, 4,000 calls. There we go, the API gateway. And you can click on those calls there. And you can get view of the actual instances and the history behind each one of those individual calls. So there's a great way to actually go in and view and troubleshoot. But this is what I want to do as a developer. I don't want to have to focus on the deployment and managing the Kubernetes cluster. I want to performance tune my application. That's the demo I wanted to show you. Let's go back to the slides. And PowerPoint, where are you hiding? There we go. Demo done. So let's also look at how to be proactive through an app lifecycle. So I noticed that all I have to do when I deploy to my Spring app is just deploy. See what you do after you deploy, my applications are automatically wired up to the Spring Cloud config server, which uses Eureka to create a service registry. My applications can interact with any Azure or external service also. And besides jar artifacts and Java archives, I can also deploy source code using the built-in VMware Tanzu build service, which creates container images from source code using AI to analyze your built-in service layers, and then it creates a custom Docker container. So the Tanzu service relies on KPAC, which is an open source Kubernetes native build engine to automate the creation and updating of containers images using cloud native build packs. Cloud native build packs separate the base image, the runtime, and all the applications into different layers, and they're quick to update only the layers that changed. While KPAC and native build packs are not exposed to the users, I can rest assured that Azure Spring Cloud is running them for me. So let's see how you actually do it. So you run AZ Spring Cloud app deploy. It goes in and analyzes your application, sees all of the layers it needs, downloads those layers where necessary, and adds them into your custom container image for you that you can deploy to your Kubernetes cluster. That is impressive. Let's also look at how Azure Spring Cloud can assist in monitoring. We saw that with the distributed tracing. So it's got out-of-the-box support for Azure Monitor, and Spring Cloud can easily visualize how my Spring applications are performing and isolating potential problems. I can also set rules for some important conditions and address issues before end users notice them. Finally, let's look at some features that allow us to focus on time to market and working in distributed teams. So introducing a Spring on Azure starters. And now this is really meant to make your code portable. You don't want to be really highly coupled to a cloud-based technology. These are open source libraries backed by both VMware and Microsoft that further simplify connection and consumption of Azure managed backing services. You don't really need to know how they work. The security, distributed caching, MySQL, Cosmos, streaming, storage, and monitor. All you have to do is consume these libraries, and they give you a Spring idiomatic way to connect and consume Azure services with only a few lines of configuration and minimal code changes. Spring starters are actually part of a really rich ecosystem that you can find many additional Azure Spring offerings. You can get more details for all of these at spring.io, and we've got a project there, Spring Cloud Azure. So as you can see from this summary, I think that I've found the platform to supercharge and autoscale my Spring Boot applications and deliver features to the market faster. It's going to let me focus on my application iteration and debugging and let the platform manage all the other responsibilities. And I know what you're thinking, but can you use it in production today? So it's generally available with a 99.9% SLA. We also have in the upcoming months, we're going to release more security related features to protect your app and data, in addition to more capabilities to monitor your application, as well as tools to simplify your daily work. We also have recently announced SteelToe.NET application support in public preview for Azure Spring Cloud. This really lets you enjoy all the features of Azure Spring Cloud for your .NET applications, built-in app lifecycle management, integration into Azure monitoring, and you can interconnect your Java and .NET microservices with zero code change, .NET Core 3.1, and it's powered by SteelToe. And if you've ever used SteelToe, it's a really rich library that Pivotal supports that has a lot of the nice features of cloud-based Netflix-style microservices. So yeah, it's in public preview. You can play around with it, and you can actually see here in this screenshot, you can get your Java and .NET services running together, speaking to each other in the same microservice environment, like I showed you there in the previous one. Okay, so I've got some great links and resources to help you get started. First of all, you can use your Azure account to start with Azure Spring Cloud today and leverage the expertly maintained Microsoft Docs references. Then you can also integrate the Azure Spring starters into your projects to produce Spring idiomatic Azure libraries. And finally, spend some quality time with our workshops to get detailed experiences with Azure Spring Cloud. You can also fill in the survey. We've got a short survey about your usage of Spring technologies. You can also, by filling it in, you can enter a sweepstake to win a 150 gift certificate. And I'm going to leave it here so you can actually, this is the final slide. I'm going to take some questions in around the technologies and great, exciting new preview features that we've mentioned today. Okay, producers, I'm ready to take some questions. Let's go through the chat. No questions just yet, so we'll wait a little bit for people to bring the questions here. We can also just go back to those previous slides and let's go see some of those other technologies there that, yeah, so you can go try Azure Spring Cloud. You can use the Azure Spring starters to interact with Azure services, and then the self-paced workshop that the Java team, myself included, has actually created and crafted to make it a really great, rich experience for you. So we got first question from Sandra. Hey, Rory, thanks for the session. How would you compare Azure Spring Cloud with Kubernetes? So, you know, friends don't let friends Kubernetes. And that's something that you say after you've been burnt by Kubernetes. I've broken and lost more Kubernetes clusters than I've had warm meals. Because it's kind of difficult to understand the life cycle, all of the technologies around that. So what Azure Spring Cloud is, it's a managed service for Kubernetes. And it is Kubernetes. And it allows you to kind of manage your Spring applications life cycles, which are different to you when you think about it to a node or a pod life cycle, because your applications, your Java applications, you want them to also be container driven, to be able to tie into distributed tracing, logging, and service registry. And you want that management to not really be reliant on Kubernetes, but to be relied on Spring Cloud and Azure Spring Cloud. So I hope I answered you the question there. Basically, it's a headache-free way of managing your Kubernetes cluster on a cloud provider, a global leading cloud provider like Azure. Great. Okay, so that doesn't look like there's any more questions. Oh, here's another one also. Keeping me on my toes, Sandra. Hi, Rory. Thanks for the session. Oh, yes, thanks a lot. Getting rid of headaches is too good. Yeah, I know. And I've done production monitoring yeah, the distributed tracing. Any other tips to share? So what I wanted to show you here and some of the nice toys, if you see here, let's go back to our code space. So this is actually a PWA. This is a website on code spaces. So let's go loading here. This isn't GitHub code spaces. This is actually Azure code spaces. And I've got the Pet Clinic full project here. And I can go into the terminal. And I actually timed it perfectly because I wanted to scale up and scale down within 7 minutes. I've got my curl here. So I'm doing this 1,000 times and I'm curling, but you don't see at the end of the transaction here. It's kind of misbehaving GitHub code spaces, but I'm curling it twice here. And let's actually reset this. It's not really behaving. It did exactly what we wanted it to do. I think so. Yeah, it's not liking that, but it sent exactly 2,000 transactions through. So have a look at GitHub code spaces. So the code spaces I used there was Visual Studio Online, and that was kind of the previous kind of technology. So GitHub code spaces, which is it's a great way to actually use code spaces. So let me show you here quickly. And you can go to github.com. I've got the exact application also in code spaces. You can go to code spaces, you can sign up also, and I've got the entire application there. You can see the Pet Clinic application. It'll start up, it'll build the VM, and you can you can integrate directly with your Azure Spring Cloud via the Azure CLI. You can see there starting the code spaces there. And eventually when this will come around, and that's where I actually hit all my transactions, all 2,000 of them from the code space. So that's a nice little tip, right? Great for demos and also great to work in the cloud. I'm in the data center that my Kubernetes cluster is located into. you know how fast the transaction is. You can see there, I'm getting like 8 milliseconds on certain, no, there's one millisecond for certain of those transactions. That's power. That's a great innovation. Great. Okay, thanks everyone. Thank you so much for your time today. I look forward to seeing you in the Twitter sphere. You can follow me on @Rory Preddy. Have a look at those workshops. That's a really great workshop, that one over there, really extensive. Azure Spring Cloud. It also shows you how to use distributed microservice transaction. You can see there we've got set up your environment, create an Azure Spring Cloud. It even goes there, build a Spring Cloud gateway, putting it all together, blue-green deployments, CI/CD using GitHub Actions, making microservices talk to each other. All of this is on GitHub. So you can go to Microsoft Azure-Spring-Cloud-training. It's a great workshop that we keep well maintained, and really great services there. Great. So thank you so much for the time today. Have a great conference, what's left of it. And I look forward to seeing you on Twitter. Thanks, producers.